Ashley, thank you.
So, if you thought that was complicated, it's about to get way more complicated. So feel free to ask questions. I'm Ashley Zelinskie. I'm a Brooklyn-based sculpture artist, and I make sculptures out of hexadecimal code. I'm going to explain what that is. So how a computer thinks is in ones and zeros. Binary code is a processor's language. A 1 means on, a 0 means off, and it's a series of on and off that the processor turns into information, into data, which is then can be anything. It can be a computer program, it can be a 3D model, it can be anything. So the computer kind of sees the world like this. So a 3D file is actually just made up of ones and zeros, or a code. And that's why you can send it through the internet to Shapeways to get your model printed. So how I use the code is I take, make this simple, I build a 3D object in a 3D modeling software. Whatever my sculpture is going to be, I draw it. Then I have a program that I wrote that reverse engineers that file into its original hexadecimal or binary code. Hexadecimal and binary code are different. And I can show you on the first slide. The top right here, the ones and zeros, are binary code. The bottom, which says 41, 73, 68, that's hexadecimal code. And what hexadecimal code is it's just binary code shortened. It's base 16. It uses a mathematical equation to basically take the binary code, which is really, really long, and shorten it. So why I'm using hexadecimal code for my sculptures and not binary code is because a 3D file for a 3D software modeling image is really, really big file. So when I make my sculptures and I put the codes back onto the original remodel, it's really difficult to fit the binary code, so I shrink it down to hexadecimal code, which is easier to put back onto a sculpture. No, that doesn't make sense now, but it will in a second. So a little background on myself. This was my first 3D printer that I built myself. Okay, so don't get too impressed. So I went to Rhode Island School of Design originally, and I was a glass blower. When I graduated school, I was tired of glass blowing. It's really hot. 2,000 degrees. It's really heavy. It was addicting. You can't really do it in New York City in your apartment. So I came up with this concept, and the concept kind of lent itself to 3D printing. So I thought, how am I going to 3D print my sculptures now? The technology really wasn't there, and I didn't have much money. Shapeways can be a little bit expensive. So I built this 3D printer. I did a Kickstarter, and I raised money for myself. And I bought the parts. My first maker.
How long ago? How long ago?
3 years ago? 3 years ago. But basically, the technology is all open source, so you can build a 3D printer at home yourself. I watched YouTube videos, a lot of them.
And this works with glass? This makes glass?
No, I totally unrelated. I don't do any more glass. But this is, it's a lot cooler, and I don't have to lift heavy things or have a fire in my house all the time. So I think this should work. The video. No, it's not going to work. I think I have to be in presenter mode to do that. Oh, no, it does work.
So what is your medium?
3D printing.
No, I mean, what are you printing? What is the materials?
Oh, it's one of these small guys that uses extrusion, the layer by layer of plastic.
So plastic.
Yeah. So this is hopefully the internet's decent in here. So this is my MakerBot's first baby steps. So basically the platform moves around, and the head, which is up top right there, will extrude plastic. There's a big wheel of plastic on the back, and it'll draw layer by layer. So this is how I got into 3D printing. I built this 3D printer and brought it back to MakerBot several days later. And I was like, oh, I built the 3D printer, it works, it's kind of cool. And they're like, oh, do you want to help? So I worked at MakerBot for a year then after that.
What did you do there?
I was a resident artist, so I basically just made designs and kind of help them troubleshoot. I was using my 3D printer more hours than anybody should use a 3D printer of this size, and so I ran into a lot of problems and was able to help them fix it. I had a lot of complaints, and that's kind of, they were looking for the feedback. So that's my baby MakerBot, and it makes something that looks like this. So you can actually get a pretty decent resolution with the MakerBot. These are about 4 inches high, like this big. They're very little because they have to fit into a building platform that's only, I think, 5 by 5 with the tiny 3D printer. And so obviously I couldn't continue making sculptures that were 5 by 5 and expect to have a career as an artist. So I decided to scale up. And that's where the story of my chair begins. So I'm going to give you an art history lesson now. This is Joseph Cassute's chair piece. It's called 1 in 3 chairs. So Joseph Cassute was one of the original conceptual artists in the 60s, and he was kind of pushing the boundaries of what art could be. It wasn't painting or sculpture or realism anymore. This is conceptual art. It's just a picture of a chair, and a definition of a chair. And this sculpture or installation of his was about questioning reality. What is the real chair? Is the chair the image of the chair? Is the chair the real chair? Or is the chair the definition or the idea of the chair? So he's very famous, very successful, but I thought I could do better than him. So I made my own chair.
The real chair is one you can sit in, I bet.
Can't sit in it. It's 3D printed, but so this is my.
Sit in it.
Can't sit in it.
It's not strong enough.
If I had it printed in a different material, it would be strong enough to sit in. But right now it's printed in plastic. It's very expensive to print metal. So this is my piece. I call it 1 in 1 chair. It's just one chair. But it kind of, it does the same, it carries the same message as Joseph Cassute's chair. This chair has a code on it. The code that's on the outside of the chair is the chair. It's the file, it's the data, the computer code for the 3D file of the chair. So if the computer was to read the code that's wrapped around the chair, it would see the chair. So it's an object that both a human and a computer can understand. So in that sense, it's questioning the reality of what's the real reality. Is it what the computer sees, or is it what you see? I read a lot of sci-fi as a kid. So this is a 3D rendering of the chair, and now I'm going to show you the real chair after it's been 3D printed at Shapeways. So not much of a difference. You pretty much get a 1-to-1. This was my 3D model, and this was my final product. So it's 3D printed in plastic using the laser technology, the first technology that we described, layer by layer. So you can pretty much get, you know what you're getting.
How much did it cost? I shouldn't ask.
It cost me over $2,000 to make.
To produce that?
Yeah. Mm-hmm. And it's about this high. It's 3D printed in plastic. And I actually am going to explain how I got it to be that cheap.
That cheap?
That cheap, right. So here's another close-up of the chair. You can kind of see it better in this picture, the code, and it creates these great shadows when you shine a light through it because the whole thing is see-through.
But that didn't add to the cost because the detail doesn't make
Detail doesn't add to the cost, so it's not the material necessarily. My issue was the size. So because Shapeways has a size limitation, only about this big, I developed this. And this is like antique furniture, used pin and hole. Yeah. So they can like put the furniture together, and you put glue in it, you stick them together, and you hope for the best. I looked at antique furniture and developed this. So it's basically, because you can only print something this big, and the chair parts were too long, they didn't meet the required size, I had to print them in 2 parts, and then somehow put them together and kind of try to make it as seamless as possible, so you didn't see that there was lines, and so it was structural integrity.
You assembled the chair.
I assembled it piece by piece. So So it didn't come out in one part, but that's not because it couldn't have, that's because it was too expensive to.
Is that pin added into the hexadecimal code, or?
Yeah, so, yeah, the pin, everything is part of it.
I mean, visually with numbers and all that, that's.
Yeah, well, and actually, what I tried to do was, so there's a pin cover that has the code on it, so that it kind of hides, camouflages that there is in fact a pin there. But yeah, that's how I kind of cut down costs, because all the pieces got to be smaller. I assembled it myself with glue and this pin stuff. I think if I was to print it in metal, I was allowed to print it. It would still be in pieces because the chair itself is larger, but the problem was the legs. The legs were too long, and they wanted 2,000 a piece to print the legs in steel. So maybe someday.
Can wood shavings or powder be used to make something in a 3D print?
3D printing in wood?
Instead of a plastic powder, could you use wood powder?
I don't think you
Yeah.
can. I've never 3D printed in wood before, though.
WOOD3, WOOD3 is the material.
3D3.
And it's like flour.
It's like the plastic. News to me. I've never 3D printed anything in wood. I usually do the plastic or metal when they apply.
Is it actually wood or is it a plastic that looks like a wood?
It's a wood embedded in a plastic rosin.
So is it like
It is.
alumine? How alumine is like aluminum
Like
and
sawdust.
plastic? Like sawdust.
And
That's
it's
what But just to give you an idea of how far apart the two different technologies are, the chair on the left was 3D printed with a MakerBot. It's a do-it-yourself at home 3D printer. And the chair on the right was 3D printed at Shapeways. So the chair on the left is struggling. That took me like over a year to make, the at-home 3D printer with the MakerBot. And I never finished it because it was extremely frustrating when the MakerBot broke, and I fixed it a million times. But that's thousands of hours of printing. And this one was like, I don't know, a couple hours. They shipped it in a couple days. Next to impossible to 3D print something large on a do-it-yourself at-home 3D printer. Just so you guys know. Don't do what I did.
Fabulous that you did it. Fantastic.
Yeah, I mean, it was a learning process. Through making this chair, it was more me in it, but I had to repair a 3D printer on a daily basis. I would come home and there would be 3D print glitch art all over my floor. And I actually set up a nanny cam to watch it. So I could actually leave my studio and sit home and watch it, and it would mess up. And I'd have to go back to the studio and pull it apart and see why it was doing what it was doing, and set the whole thing up again and run it again.
That's
Yeah.
I know. It's not funny, it's tragic.
The funny part is the nanny cam.
Yeah.
Where is it doing the glitch art?
All on my studio floor.
Yeah.
It's actually pretty cool stuff, though.
Yeah.
If your model shifts over even a little bit on the platform, it keeps printing because it doesn't know that it's screwed up. So just keep layering, and you get like this weird, like it's like glitch art. Like everything's just moved over further and further until it falls out, and then it's on the floor, and then it's printing spaghetti. So. But definitely buy one, they're really cool. This is something that I printed on the MakerBot as well, but also in parts, because it only has a 7 by 5-inch bed. You can expand, you can get like expansion packs for it, like tools that make the rods longer, and like boxes that you can put, you can actually build it into any size that you want. Too much work. Use Shapeways.
Well, what is the MakerBot good for at home? For fun and
Good question.
making things?
The MakerBot is great if you want to learn physical computing and have fun doing it. Like, I built the 3D printer. I enjoy building a 3D printer. It broke a lot. It was fun the first 100 times it broke. It became less and less fun. But I know how to build a 3D printer now.
So are you saying that the MakerBot is really
No, it's good if you're making small things, but small things you can definitely print with the MakerBot.
Like your necklace, kind of, sort of.
Yeah, like you can print jewelry, you can print small sculptures, you can print pieces of something larger that may or may not have to be fit together. I like to print my sculptures tiny before I decide if I want to make them bigger, spend the money to make them large. But yeah, I wouldn't rally against MakerBot. It's well worth it, but I mean, as an artist, when you're trying to sell sculptures, collectors want something a little bit more substantial than 5 inches.
So you use it for prototyping?
I use it for prototyping, yeah. And I can show you how far that prototyping can get. So this is the cube that I showed you here. Up here, this is my MakerBot cube. This is my shape waist cube. So went from 5 inches to 10 inches. And it's a lot nicer, smoother.
Is the MakerBot less expensive than, say, one of these?
MakerBot, you're going to spend like $2,000 on a MakerBot, but you can get a pretty big one right now for $2,000. It's like, I think the building platform is 7 by 5 by 7. So you can fit a decent size in there. And I printed a whole chair. I printed this whole chair on the left with MakerBot of that size.
So it's better than this one.
This is really tiny. And they're making their MakerBots better and better. But you can also still get the kits to build them yourself, which I highly recommend because you struggle at first to build the thing, but then you know how to fix it when it breaks, and it's going to break. Why? This is something I printed at Shapeways as well, the tetrahedron. So after I developed my chair project, I developed this body of work. It's called reverse abstraction. Another computer lesson, ready? Okay, so reverse abstraction. Abstraction is a term used in art, but it's also a term used in computer science. Abstraction in art means the further and further away you get from realism, the more abstract an image becomes. But in computer science, it means the opposite. The further and further away from binary code you get, the closer to a user interface. You get something that a human can understand. That is abstract to a computer. So a computer reads ones and zeros. So if you're using Google, if you're looking at a Google browser, that's so many abstractions away from binary code, and that's abstract to a computer. So I used this terminology and kind of fused it together. So reverse abstraction is the term I use for my sculptures that are abstract to a computer because they are a three-dimensional shape that a human can understand, that abstract to a human because of the code that the computer can understand. Everybody follow that? Mm-hmm. All right. So I did this series within my body of work that I call reverse abstraction, and it's called the Platonic Solid series. So the Platonic what? Platonic solids. Platonic solids are perfect geometric shapes. Geometric shapes that are throughout geometry, science, and art history are considered to be beautiful, perfect geometric shapes. Easily divisible, divisible sides, symmetrical, and they reoccur over and over again in science and art history. So I chose to do a series of them. Then there's only 5, there can only be 5 mathematically. So I thought that was a good starting point for making a small series.
What are they?
The hexahedron, the octahedron, the dodecahedron, and the icosahedron. Depending on sides. So this is my tetrahedron. This was my hexahedron. And then later on I made a bigger hexahedron and tetrahedron. I'll show you that later. This is a piece that I did. This is the Mona Lisa in hexadecimal code. And the code is laser cut on the exact same size canvas as the actual Mona Lisa. So if a computer was to read this code, it would see a high-res TIFF file of the Mona Lisa. Google right now is doing a project called Google Artworks, where they are taking high-definition pictures of artworks in order to preserve them. So there's also, in 3D printing and scanning, there's this level of preservation The technology is being used to preserve works of art, which I thought was really cool. People are 3D scanning the sculptures in the Met, so if the Met ever explodes, they can just 3D print, like.
So would they revert back to the original? The code would revert back to the original Mona Lisa?
It would be a high resolution to file of Mona Lisa, yes.
And so,
Like the best reconstruction of Mona Lisa you can do with computer. So there's people scanning all these artworks, taking high definition pictures of artworks. So if they ever needed to be recreated, you could do it basically.
Would they be confused with the original so that they
It wouldn't be a painting necessarily, it would just be the image. I think you could probably recreate off the image, but it wouldn't be the Mona Lisa, just the image of the Mona Lisa. But the sculptures, you could 3D print them. Like if a ceramic vase in the Met shattered, you could 3D print it, and you could 3D print it in ceramics. So you could basically have the same vase. Yeah. You can 3D print it right back. So I really like this art preservation thing that's happening. So I'm kind of like working with that too. So this is the Mona Lisa in hexadecimal code. Art for human and computer. Yeah.
What did you say the material was?
It's canvas. So I took canvas for my two-dimensional pieces where I'm recreating masterworks, master paintings. I laser cut the code onto the original size canvas, onto actual canvas.
So where is the Mona Lisa? I'm sorry, I didn't see her. Am I missing something?
Oh, you're not supposed to see her. You're not a computer. The Mona Lisa's in the code. So do you see the code that's on the material? It's laser cut. If the computer was to read that, it would be the Mona Lisa. And then I'm working on a series right now where you can see the Mona Lisa too. So it would be a printed canvas laser cut, so you can kind of see the Mona Lisa, and the computer can see the Mona Lisa.
so one question that I think is important to me. The artifacts that have been found that are destroyed, that some part of them is gone, this could actually recreate that part that was missing.
Yeah.
In other words, by using the code.
By using the code, by 3D printing a file, yeah.
When you create a file for 3D printing, what program do you work with?
Maya and some recording. But the program that breaks up the file into the code, I mean, that's how your computer reads it. You just have to be able to reach down into it. So my brother, who's a computer programmer, and I wrote this program called Catbite. And you can actually download it. It's on GitHub, but it can take your files and you type in the file name and it spits back out the code as a text file.
Catbite is on what?
GitHub?
GitHub?
Yeah, that's where people upload programs.
What form are we looking at there? What is that? Another way.
So this one, this is it hanging up. This is the Mona Lisa hanging up, so it's the canvas on the wall, as you would see a painting. This is to show that it's a material, that it's a pliable material. So you can, you should that.
Drape.
You can drape it, it's material, it's canvas. This is a close-up, and you can see how the code is laser cut into the canvas. What's my next slide?
So what part of this excites you?
All of it.
All of it?
I like building the actual machines, the soldering the wires, programming the chips to tell it what to do,
Amazing.
creating the files to print.
And so was your training in computer science?
No, I was a glass blower at ISD. I taught myself this.
You missed the beginning.
Yeah, I also taught after school. I've only been graduated for 3.5 years. So
Glass blower to 3D printing?
Yeah. Well, you have a mind of like a sculptor then. You can think in 3D forms. But yeah, I watched YouTube videos and read a lot of books for a year. And then now I can do this. So it's not that hard to do it.
Oh, no, of course not.
So this is a laser cutter. So how I got from the 3D printing to the laser cutter was kind of via the Mona Lisa piece. So I was already familiar with the technology of laser cutting as an alternative to 3D printing. So I've been asked to scale up my sculptures even further because shape weights, again, size limitation. And I got an email from the US government one morning. And oh dear, scary, right? And they asked me to make a large-scale piece for their consulate in Saudi Arabia. And at first I thought it was a joke or a scam. Someone on Craigslist trying to get me to send a check or something, I don't know. And I deleted it. And then I thought about it for a second, I was like, maybe that might actually be a thing. I don't know, I didn't want to get my ego up, but I sent it to my dad's lawyer, who is also an art collector. And she said, yeah, the government just emailed you. And they asked me to make a 5-foot sculpture, make my sculptures into like a 5-foot sculpture. So I had to figure out how I was going to scale up. And I thought of the Mona Lisa piece and how laser cutting really doesn't have those size limitations. So I started laser cutting my 3D sculptures. So that has to be done in pieces. So this is aluminum being laser cut. So large sheets of aluminum that can be any size. And they run them through this laser cutter, which uses the same program as one of these. With these little ones, it uses G-code. G-code's what, how the 3D printer thinks, how the at-home 3D printer thinks. So when I was using the laser cutter, we were using G-code, and I was like, oh, I know what that is, be 3D printing. So they 3D printed, or they laser cut all these sheets and then welded them together to make this. So this is my cube, the tiny 5-inch cube that became the 10-inch cube is now a 5-foot cube.
And now, that was at Shapeless?
No, this is, I have a fabrication studio that does this.
Okay.
But this just goes to show you, your idea that starts off 5 inches can be 25 feet.
I see.
With not that much in between.
So you're outputting hex as a text file and then converting the text file into CNC basically.
Yeah, so these are vector files I've drawn in Illustrator. Because I had to take my 3D model then and kind of disassemble it into sides to be laser cut, draw my vector files.
And how much does that cost?
The government's paying.
Your taxes are paying for it. So I'm not going to tell you. Yeah.
Is that all the hexadecimal code for the Mona Lisa, or did you cheat?
No, it's all of them.
It's all there.
Do you know how tiny it looks like a lace?
I would think it would be more.
It's hex code though, so it's binary code base 16 divided by 16.
Cool.
So it's still a pretty big file. It was really difficult to convince a laser cutter because they always quote you and they're like, oh yeah, we can do that. That'll cost you $100, and then they hand it to you and they're like, that took 1,000 hours of laser cutting or 3D printing. It's gonna cost you a lot more, and I'm like, oh, okay. So I'm always quoted probably like 50% less than anything actually comes out cost.
So by changing the code, you're able to lessen the price of your,
By changing the code?
yeah.
Oh yeah, if I was printing binary code, it would be, there'd be way more of it. So yeah, the code is shortened, therefore it's cheaper. That's just to tell you, scale, that's me. So it's as big as me, it's a little 5-inch, then 5 feet now. So then I started doing larger sculptures. This is a piece, I call it the financial equation. And it is a... So you call it what? The financial equation. It's a triangular sculpture, but it's an optical illusion. So I was an artist, very poor, had to make a sculpture for an outdoor exhibition for Leslie Keller Gallery. And I only had so much money, because laser cutting costs a lot of money. I had to create my image using an optical illusion. So using 3 pieces of laser cut aluminum, here's my video. Using 3 pieces of laser cut aluminum, I was able to make a 3-dimensional image of a 3-dimensional triangle. So you walk around it.
Where is this?
Leslie Howard Gallery did a pop-up show in Bushwick. She did an outdoor sculpture garden. So it comes together.
Move the mouse.
Wait, it comes together because you're walking around
Because you
it?
walk around it because of foreshortening and it's an optical illusion. So
What is it?
sometimes we have to cheat to make things work. And then I'm also doing a series, these are also 3D printed at Shapeways. This is alamide, it's 3D printed alamide, and it's pi, but instead of having the code for a 3D file on the object, this is actually pi. As much pi as you can fit onto the object. So this is a series that I'm doing with math. So same idea with the code, but only with its mathematical equation instead of its three-dimensional file.
I'm sorry, what's alamide?
Alamide is plastic and aluminum composite 3D printed. And this is the golden ratio. So it's 3D printed in gold. Well, not all gold, but gold-plated steel. And then the object has the golden ratio wrapped around it. So the equation for the golden ratio.
I'm so glad you think I know what you're talking about.
Very special. Sorry, if you have questions, please ask.
Oh, no.
It all makes sense in my head.
I just felt so harsh.
Yeah, it's the ratio that makes the perfect spiral.
Yeah.
The spiral is like the nautilus shell. The spiral is found in hurricanes.
Yeah.
It's like the natural occurring perfect spiral. And this is
But I didn't realize you could put that in a code. You could code.
well, it's an equation, so the numbers on this aren't a code. It's the actual equation for that spiral.
But then you have to convert it into a code to make it.
Oh, well, I just modeled it in
He has
3D.
the actual number there, 1 to
Yeah.
1.6 million.
Yeah. You've got it. That's it. This one's a little bit easier to understand. This is a Tibetan prayer wheel. So Tibetan monks use a prayer wheel, which they spin. And there's a mantra inscribed on the outside of the prayer wheel. And as they spin the wheel, they say the mantra and they meditate on it. This is the prayer wheel, but instead of having a mantra on the outside, it's the dialog on his Twitter feed. So he actually has a pretty good Twitter following. Yeah, he tweets every
Is he
day.
okay with it?
No, I'm sure he's fine with it.
I'm sure he is.
He's fine with everything. Yeah, because I thought, tweets, what are tweets but small mantras?
He would love this. Are you
Yeah.
kidding?
And I showed this on a couple benefits for Free Tibet. So that's good.
It's beautiful.
Also 3D printed at Shapeways in plastic.
Yeah,
It does spin. It spins, which you can do at Shapeways. You can have everything be different parts and it comes out one piece.
Does it update the Twitter feed?
I mean, it could, but no, it doesn't.
you could manufacture these. Correct?
Shapeways, shapeways.com.
Are you like a saleswoman for Shapeways?
No, but
Everyone is.
everyone is.
Oh,
I got fired from MakerBot, so I'm hoping. Shapeways is my next step. So this is 3D printed with my MakerBot. I did a Mobius strip, again with the code of the Mobius strip on the outside. But then I scaled it down. So the same way that I scaled my sculptures up, while I was scaling my sculptures up to be in the sculpture garden, I was also scaling them down to become jewelry. So the one on the left is, for scale, you can see it's sitting on my computer, my laptop. It's really tiny, it's a pendant, but it's 3D printed in silver, which you can do at Shapeways. It's pure silver. Pure silver. Should be wearing it. Yeah, no, it would be. This is my last slide. This is the possibilities of 3D printing. It can be as tiny as the pendant or as big as the person.